Okay. So in our last class, we started discussing about stack. Okay. So in stack, uh, the stack data set is called as a last in first out. Okay. If you take a stack, in stack you can add item or delete the item from only one end. Okay, so addition and deletion of elements from a stack is restricted to only one end. So this is what called as a stack. Stack is widely used in many areas. Okay, mostly in compilers. So evaluating expressions. So that we will see as an application. Once this introduction to stack and implementation is over, that applications we will discuss. Okay, so in our previous class we discussed about introduction to stack and then the push operation. Okay, so the stack operations, there are majorly three basic operations: push, pop, and stack top. Okay, push is adding an element into the stack, pop is removing an element from the stack, and the stack top is checking what is the value in the top of the stack. Okay, so this is what called as three basic stack operations. Okay, in that, in our last class we discussed about push operation, the algorithm for push operation we discussed. Okay, so these are a major stack algorithm we are going to discuss. Okay, so create stack we discussed already. Okay, and it's equivalent C implementation code. So this is what the C implementation code. So we are going to use two structures. If you are checking this structure, the same structures we used in list also. Okay, here I have given the name as a struct stack. Instead, in linked list, we used it as a struct list. Okay, and in here integer count we used, then struct node head we used. Here we are using the variable name as a top. That's it. Instead of the variable name head, here we are using it as a top. Otherwise, the two structures are same as the structures that we used in the linked list. And create stack also. Okay, there we used it as a create list. So wherever we used list, here I am using stack because we are going to implement the stack using linked list. Okay, so we are creating the stack and initializing the count variable to 0 and top to null. Okay, so this is C implementation for the create stack algorithm. Then push we discussed in our last class. Okay, so don't get confused between the implementation, means the diagrams. Okay, so here they have given the elements, the data items, one below another. In list, the same operations on the same list will be means illustrated, but it will be illustrated in a horizontal way. Okay, first red and then next blue and then green. Here one below another they are representing it. So since whenever we are assuming stack, we are considering it as a vertical structure. Okay, that's why the picture is represented in vertical structure. Okay, green above that blue and above that red. Okay, otherwise the two, whatever the diagrams we discussed in the linked list and whatever the diagram here we are discussing, both are same. Okay, you can check these two diagrams also. Okay, push operation means inserting a node into the stack. So for inserting a node into the stack, first we need to create a new node. Okay, so in our A, okay, before in this diagram you can see first we are creating a new node, and in new node we are storing the data, whatever the data we need to store, the data we are storing. Now this new node's link, okay, so it must point to the blue. So blue's address is available in top. So new node's link equal to top stacks top. So this address we are going to store here. After that, the stack top need to point to this new node. So stack top equal to new node. Okay, these two assignments we need to do. Okay, these two pointer assignments we need to do. So after assigning this, the stack will look like the second one after insertion. So top is pointing to red and red is pointing to blue. Okay, so now we inserted red in the beginning. Okay, so stack means insertion will happen in the front only. Okay, in the top. Okay, so only one end. So insert beginning in the linked list, that algorithm and push algorithm both are same. If you are learning that algorithm, the same algorithm you can write it here also. Okay, now let us check the C implementation. Okay, so this is the algorithm. First allocate the new node, store the data in the new node, then set new nodes next equal to stack top. Okay, new nodes next, what address we need to store means the whatever the address available in the top, then stack top. Now the top must point to the new node because new node must be in the beginning. Okay, in the top of the stack. Okay, so this is the algorithm for push operation. Now the C implementation. See here, integer push. So we are going to return true or false, 0 or 1. Okay, that's why its return type is int. Push struct stack. Stack we are passing and integer data. Whatever the data we need to insert into the stack, that we are passing. Now we are creating a new node. Okay, struct node. Now if stack is null, it is not possible to enter insert value into the stack. So we need to return 0 error. And then new node we are creating. Suppose any error in the malloc statement, it will return null. So if new node equal to null means stack overflow error, return 0. Next is the new node. Suppose if these two if conditions are not satisfied, it will come to the next statement. So we are storing whatever the parameter data we are receiving, that we are storing it in the new node. Okay, now these next two statements are important. Pointer changes. So new nodes next, the new node must point to the address which is currently available in the stack top. So new nodes next equal to stack top. Okay, and stack top must point to the new node. So stack top equal to new node. These two pointer changes are very important in case of push operation. After that, increment the count variable. Okay, finally return 1. Okay, if this return 0 and this return 0 is not working. Okay, so if it is not means, then return true. Okay, this is a false case and this is true case. Okay, this is push implementation. Now pop operation. So pop operation means we need to remove one data from the stack. Okay, so pop stack sends the data in the node, whatever the node available in the top. Okay, that data will be returned to the calling function, and also it removes the top element. After the node has been logically deleted, it is physically deleted. Okay, physically deleted means we have to use the free function. Okay, memory release function to release the memory. Okay, then we need to decrement the count. Okay, count must be decremented by 1. Okay, so if you are checking the pictures given here, okay, now top is pointing to red. So create one temporary pointer, delete pointer or temporary something. Okay, now the temporary pointer equal to stack top. Okay, whatever the stack top is pointing, the same must be pointed by the temporary. Okay, now stack top must point to the next data, that is blue. Okay, the blue is available in the temporary nodes next. Okay, so what we need to give means stack top equal to delete pointer next. Okay, delete pointer next. Now the blue data, this node's address will be stored in stack top. Now directly the top will point to blue and the red will be pointed by only the delete pointer. You can recycle it. Free delete pointer if you are giving means whatever the memory allocated for this red node, that will be deleted, recycled. So in the second picture you can see it. Okay, so recycled, free. The memory is recollected and the top is pointing to blue now. Okay, now let us say the algorithm. See here, we are passing two parameters, so stack and data out. In data out, whatever the element we deleted, that element's data we need to store it. Okay, and then it returns true if successful, false if underflow error. Okay, if stack is empty means success is false, else set data out to the data. Okay, the top data we need to store it in data out. Then see here, the 2 and 3 the second statement is important. Stack top equal to stack top next. Okay, whatever the element pointed by stack top, it's next. Okay, then decrement the stack count and set success to true. Okay, so here the temporary variable not used in this algorithm. Suppose if you wish to use the temporary variable means here you can give it, okay, one, that is temp equal to stack top, then stack top to stack top next, no problem. Then finally free, two, three, and fourth point is and 5, 6. So here if you're checking, okay, temp equal to stack top, set temp to stack top, then data out to top data, then set stack top to stack top next, and free temp. So we are removing the memory allocated to temp, decrement stack counter, set success to true. That's it. So this is pop stack algorithm. Now let us check the implementation, C implementation. See here, we are passing stack and data, and then we are creating one temporary node, struct node start temp, okay, and this is underflow error checking. Now temp equal to stack top, okay, whatever pointed by stack top, the same must be pointed by temp also. Now data equal to temp data, okay, the temporary nodes data, and stack top equal to temp next. Here I have given it as a temp next. You can give temp next and the same, okay, we can use the other way also, okay, that is a stack top equal to stack top next, stack top next, both are valid. Either you can use the first statement or second statement, okay. So here if the stack top is what, it is temp, okay, temp next is same as stack top next, okay, and finally we need to free the temporary memory, okay, memory, whatever memory allocated to temp, that we need to delete it. So this is the pop algorithm, okay. We discussed about push, and then now we are discussing the pop implementation, okay. So the next is a stack top. Sometimes without removing the top of the element, we may be in need of checking what is the value available in the top of the stack, okay. So simply reading the stack top. So for that we can use this algorithm, stack top algorithm. The stack top algorithm sends the data at the top of the stack back to the calling module without deleting the top node, okay. It is more or less equal to the pop, but here we will not perform the delete operation, okay. So here also stack and data out, two parameters we are getting it, and return true if data returned, false if underflow error, okay, checking whether the stack is empty or not, else data out equal to data in the top node, set success to true. That's it. See here we are not doing any pointer changes, we are not deleting any node from the stack. So this is the third algorithm, that is stack top algorithm, okay. Now let us check the implementation, okay. So implementation is very simple compared to the push and pop algorithms. So integer stack top, stack and data we are getting. So this is the underflow error checking. So if no underflow error, data equal to stack top data, whatever the node pointed by stack top, it's data, okay, return 1. So this is the stack top operation, okay. Now let us check the implementation. Now I hope the coding window is visible to you, okay. Here, see here, this is a list. Yesterday we discussed about this list example. Here whatever the structures I have used, struct node and struct list, okay, the same type of two structures here also I am using, node and stack. Instead of the structure name list, here structure name is given as a stack, and the second variable, instead of giving star head pointer, here I am calling it as a top pointer, okay. Simply because the structure is stack, here we need to maintain the top pointer, okay. So here I am renamed as a top pointer, okay, and create stack, okay. You can compare the create stack and the create list functions, okay, both are same, okay. Then push operation, here insert node operation. See here, this is insert beginning operation, So this code and the push operation code both are same. Okay, because the implementation of the stack here is using linked list. Only the function name is different. Instead of giving the function names insert and delete, here we are giving the function name as a push and pop. Okay, and totally push operation, pop operation, then stack top. Three algorithms we implemented, and fourth one count also here we implemented. Then from main we are calling all the functions. First we are calling the create stack. If any error in the create itself, we are displaying the message as a stack creation error and returning. Okay, otherwise we are performing the rest of the operation: push, pop, stack top, count, exit. All the operations we are performing. Let us check the execution. Now see here the first operation. Let us first insert 100. Okay, now value added successfully. Now if you're checking 3 is a stack top. So in stack top 100 is available. Okay, 100 is available. Now second, one more value I am inserting 200. Now if you're picking the stack top, it will be 200 because 200 the value we inserted last. So it will be available in the stack top. Okay, now again one more value 300 and one more value 400. Okay, so totally 4 values I have inserted. Okay, now if I'm checking stack top, what will be the value available in the stack top means 400. See here, stack top is 400. Okay, now let us execute the pop functionality. Now if I'm giving the pop, whatever the top element 400, this will be removed. Okay, now pop operation, so 400 is removed. Now if I am taking the 3, that is stack top means what will be the value in stack top? What will be the value now?
300.
Yes, correct. So before 400 we inserted 300. Okay, so let us check it. See here, stack top is now 300. Okay, now let us again remove 300. Okay, now stack top is 200. Okay, again pop. Now stack top is 100. Again I am trying to pop, 100 is removed, and suppose if I am calling stack top, you will get no stack found, underflow error. Okay, or 2, it is not possible to pop from empty list, underflow error. Okay, so this is what push, pop and stack top operations. Okay, what we can do means we can try to let us discuss about the functionality, and finally once again we will execute it. Okay, now the count functionality. Okay, so as per the stack operations, we cannot traverse the list. Okay, so we cannot go to each and every node and declare a count variable and incrementing the count variable. It is not a way of it is not an operation of stack. Okay, visiting each and every node is not an operation of a stack. In stack, all the operation must be only at the one end, that is top. Okay, you cannot move to the next node until you remove the first node. Okay, it is not valid operation. So how to get the stack count? Okay, suppose if you have the metadata structure, okay, the metadata structure, stack structure, in that if you have a count variable, then that count variable you can use to get the number of elements in the stack. So whenever a push operation is happening or whenever a pop operation is happening, that time you can increment the count and decrement the count, keep on updating the count variable. So when the stack count function is invoked, you can return that count variable. Okay, please remember that don't implement the for loop version of the count operation. Okay, whatever we will do it in the list. Okay, that kind of implementation, don't do it for the stack count operation. Okay, using iteration from the top, next node, next node, next node. Okay, incrementing the count variable, that kind of logic, okay, algorithm or code, don't write for stack. Okay, it is not a valid operation for the stack count. Okay, if you are having the count variable in the meta structure, then the count variable can be returned for this functionality. Okay, now let us check the algorithm. If stack is empty means the success is false, otherwise return the count. Okay, count equal to stack count, return the success. Okay, so you are updating the count variable and returning success. This is the implementation. So we are passing two parameters, stack and count. If stack is null means no stack found error, means stack underflow or overflow errors. Otherwise count equal to stack count, return one. Okay, we are passing a reference count. In the count we are storing stack count and returning one. Okay, now let us check its implementation. See here, stack count, the same code we used here. Okay, now let us check the execution. 100. Now count equal to 1. Okay, again 1000. Okay, now again count is 2 and the stack top is 1000. Okay, again 4000 I am inserting. Now count is 3 and the top is 4000. Okay, again one more 5000 and then count. Okay, now count is 4. Okay, count is 4 and then top value, whatever the value available in top, what is the value available in top is 5000. 5000 is in the stack top. Okay, so this is stack top now. Okay, now let us change it, let us do the pop operation. Okay, 2 5000 popped, okay, again 4000 popped, 1000 popped. Now let us check count. Okay, so I removed 3 elements. So count is uh, now 4. Okay, it means the count is not decremented in the pop operation. Okay, so let us do it. So in pop operation, see free temp, after freeing the memory, the count is not decremented. Stack count minus minus, stack count minus minus. Now let us compile. So 1000, again 1, 2000, and again 1, 3000. Totally now, how many elements are there means 3 elements there. Okay, count is 3. Now pop, I removed one element. Now again 4 count. See here, now count is decremented 2. Again I am popping, then checking count. Now only one element. Again popping and checking count. No stack count. So all the values are removed. Okay, so this is stack top operation. Okay, now let us try to convert the same program, okay, into a string reverse program. How to implement string reverse using stack. Okay, so I am copying this program and creating a new file. Okay, so here the data, okay, I'm going to store character data instead of integer data. I'm going to store character data. So now character data. Okay, so now click here the same stack program. Okay, I have implemented the stack program, the same whatever the functions I have used here, the same functions I have used: push, pop, create stack. Okay, I have used it, but the data type, okay, in the node, struct node, the data here in the first example I have used it as a integer data. In the second example, I am using the data as a character data. Okay, so I am going to use the structure for reversing the given string. Okay, it may be looking like odd. Okay, so to simply convert the given string into reverse, okay, you can use a simple for loop. Okay, but how the stack is working, to understand that, we are performing the string reverse operation using stack. Okay, create stack, and then push operation character data, then pop operation also character data, and then stack top operation character data. Okay, so here we are not using the stack top, so this functionality not required, and get count also not required. I am commenting these two functions. I am commenting these two functions. Okay, so now here what I am doing means, I have declared one character array, then first I am creating the stack, and I am getting one string, enter a string, scan of s1, then I equal to 0, string length. Each character I am taking characters one by one and pushing into the stack. So push of stack comma s1 of I. Okay, zeroth character I am inserting into stack, first character I am inserting into the stack, second character I am inserting into the stack. So I am taking over each character from the string and pushing into the stack. Then in the second for loop, what I am doing means, I am popping, I am removing character from the stack, okay, repeatedly until n characters, and printing it on the screen. Okay, removing and storing it in temporary character, and the temporary character I am printing it on the screen. Okay, now let us check the program. See here, I am giving the input as a Shastra, and the output is a reverse. Okay, you can give any string. Welcome. Okay, it's reverse. Okay, so this is one simple application. Okay, so how to use a stack to print the reverse of a string. Okay, this is one simple example. Okay, so only push and pop operation we are using it here. Okay, so this is a string reverse program using stack. Okay, so whatever we discussed so far, if you have any doubt, please ask now.